guys, so welcome to session 4. We're going to be looking at factorising graphs and linear functions today. So what we're talking about is how to factorise. So essentially, when you've got a big long expression, you want to find a way to put it into a bracket. It looks nicer, it's a little bit neater, and you get the marks in the exam question, and that's kind of why we do it. So if you have a look at this example, if we have a look here, we've got 3a plus 9ab plus 15ac. So you look at it and you go, what's the same in the numbers? So you look at just the numbers first. You're like, there is, each of those numbers goes into the 3 times table, so we take it out. Then we look at everything else and we say, is there anything else that's the same? And you're like, there's a as well, and we can take that out. And then you say, what do I times 3a by to get 3a? Well, I times it by 1. To then I times a 3 by 3 to get the 9, and I've got to put the extra b in. And I've got to times the 3 by 5 to get the 15, and then I put the extra c in. So what you have here would just be the 3 taken out. So if it's a 2-mark question, you may only get 1 marks. So that's like factorising, and we'll do some questions. There's a bit of a mix of topics here. Then we've got graphs and plotting coordinates. Remember, it's always, I used to learn it as along the corridor before you go up the stairs. So it's the x first, and then it's the y. When you're plotting a graph, you can use your calculator. So we'll show you how to do that. But also you make a table. And if it's a non-calculator paper, they probably will have it written out for you. So you can put that table together. But we'll look at some questions in a bit. And that leads on to lines. So we're just going to be talking about straight lines at the moment. No curves, just straight lines. And they're off the form. And you always hear y equals mx plus c. Don't worry too much about it. It just tells you the slope and the intercept. So this is just a really quick overview. When we do the questions, we'll go a bit more slowly through them and then it'll make sense. And the last bit we're going to look at today is simultaneous equations. So there's 2 ways to do this, by substitution or graphically. So algebraically or graphically. If it's a non-calculator paper, it's easier. We can check everything, but you shouldn't really ever get simultaneous equations wrong, because you can always plug numbers back in and check if you've got it right. So those are the list of topics. I know they're all a big mush, but it's trying to get through this whole syllabus before your exams. So you'll get a sense of a little bit of each of them, and we'll go through at least 1 question from each. So there's a few examples to start with, and then we've got the exam questions, which are sort of the foundation level exam questions and should help it make a bit more sense. Okay, so let's have a look at some of these examples. The first one is to factorise. And again, we look at the numbers first. We say, what times table do all of these numbers go into? We've got 3, 9, and 6. So hopefully you recognise they all go into 3. Then you say, what's the same? What letter is in all of them? Now, if we have a look, there is a letter that's in all of them, and that's X. So we can write that outside. And then we put the bracket. And we say to ourselves, what do we times 3x by to get 3xy? Well, we already have the 3 and the x. We need an extra y. And then we do the same thing. What do we times 3 by to get 9? Well, we times it by 3, and the x is already there, so it can stay outside. Next one, plus. What do we times 3 by to get 6? Well, we times it by 2. There is already an x there, so we get to add the y. And that would be fully factorised. I know it doesn't look that much nicer, but that would be fully factorised. The next thing is when we're thinking about straight lines. So let's just think about lines for the moment. So we've got a straight line. Where it crosses the y-axis, this is called my y-intercept. So where it's intercepting the y. So if you like, this is your plus c in that equation. Your m, where you've got y equals mx plus c, is your gradient. It's how steep the slope is. If you imagine it was a hill, how hard would it be to climb up? The steeper the slope, the higher the m. Now, if you start low and end high, So you've got a line, sorry, I realised my camera's probably backwards, going upwards, then that's going to be a positive slope. If you're going down like this would be a negative slope. Now, if we talk about things being parallel, we're talking about two lines that never, ever, ever meet. So for two things to be parallel, the gradient has to be the same. So there's some definitions for you. If two lines are parallel, it means the m is the same. And if they're perpendicular, they're what we call the inverse reciprocal, which means you're going to flip the gradient and change the sign. So for example, if the gradient was, I don't know, let's say 3/2, the perpendicular gradient is you'd flip it 2/3 and stick a minus. If it was just 2, now you imagine that 2 as being 2/1, you'd flip it round to make a half and stick a minus. If it was -1/4, you'd flip it round, which gives you 4/1, which is just 4, and change it to a positive. So that's how you think about gradients and parallel and perpendicular. Right, let's go back to the question. So we've got an equation of a line that is parallel to 3x plus 4. So if it's parallel, we know the gradient is the same. So straight away we can write y equals 3x. And then we can have any plus c. We can leave it as just y equals 3x. We could choose, I don't know, 1008. It doesn't matter what your plus c is. Anything where they've got the same number in front of the x will make that line parallel. Then we've got write an equation of a line that's perpendicular. So we're looking at the bit in front of the x. In this case, we've got a half. And if you remember what we said, we're going to flip it and change the sign. So we're going to make that -2. So we've got -2x. Again, this is quite sufficient on its own, but we can add whatever plus c we want. And that will be perpendicular. Right, now an equation of the line always y equals something x plus c. So if it's not in that form, you know you need to change something in order to make it look like that. So let's think about what we might need to change. At the moment, we want to get y equals. So we're going to move this 3x onto the other side. So we get y equals -3x plus 6. So we can see that the gradient, the bit in front of the x, is -3. And if it's parallel, it's got the same gradient. So we get y equals -3x, and like we said, we can add any number or just leave it as -3x, which means it goes through the origin. Right, we'll put 6 there. And now we want an equation that's perpendicular, but again, we need y equals. So this time we're going to get rid of this 2x on both sides. So we get y equals -2x minus 5. So we can see here the gradient is -2. So remember, if it's just a number, it's the same as -2/1. We flip it, make it a half, and the minus becomes a plus. So y equals a half x, and we can leave it like that, or we can just add a number. Right, so now we've got some simultaneous equations. So step 1, you're going to write them on top of each other and label them. Call 1, 1 and 1, 2. Okay, so we've got 1, 6x minus 4y equals 14, and 2, 7x plus 2y equals 11. Now these are your rules. If first of all, you want to make either the x's or the y's the same, but you can't add and subtract. You can only multiply everything by something. So in this case, we're going to take the second one and multiply it by 2, because I want to try get the y's the same. Ignore the signs for the moment. We want to make the y's the same. So my new 2 becomes 14x plus 4y equals 22. And now I want to get rid of that 4y. Now, if I've got a minus and a plus, I have to add them together, because -4 plus 4 just becomes 0. So if we rewrite them here so you can see it clearly, these stays the same. Your new 2 is 14x plus 4y equals 22. So if I add them together, 14 plus 6 gives me 20x. The 4y's cancel each other out. 22 plus 14 is going to give you 36. Okay, so that doesn't come out as nicely as we'd like. So x will be 36 over 20, and you can leave it like that, or you can simplify it down. You get 9 over 5. Now to find the y coordinate, you would sub it back into 1. So you get 6 times 9 over 5, so I'm putting it back into here, minus 4y equals 14. So we've got 6 times 9 over 5, so 6 times 9 is 54. 54 over 5 minus 4y equals 14. We want to get rid of this, remember from what we've done before. All right, if you had something with these sorts of numbers, it would be in a calculator paper. So you'd be able to use your calculator. You get 16 over 5, divide through by minus 4, and you get minus 4 over 5. And that would give you your answer to those simultaneous equations. So if you've got a calculator like this one, you're able to use it to do simultaneous equations. You go to menu, you go to equation, which is A, you choose simultaneous equation, you choose your number of unknowns as 2, and you just substitute the equation straight in. So if you have to show you're working, you can't use this. Well, you can use it to check. And if I put it into check, it gives me my answers as 9 over 5 and minus 4/5. Right, let's do the next set. So in the next set is really similar. So again, the signs are different. We've got 3x plus 2y equals 7. And we've got 5x minus y equals 3. So in the second one, we're going to multiply it by 2. That gives us 10x minus 2y equals 6. And that's our new 2. Because the signs are different, we add up. So we're going to do 3 plus 10, 13x. The 2y and the minus 2y cancel each other out. You'll have 7 plus 6 to give you 13. So x is 1. You can sub it back into the first one. So you've got 3 times 1 plus 2y equals 7. So 2y equals 7 minus 3, which is 4. So y is 2. And I didn't do this in the previous one, but because I checked on the calculator. But if it was a non-calculator, you can check by putting it back into your equation, but back into your 2. So you get 5 times 1 minus 2, which equals 3. So you know you've done it right. And that way, you guarantee yourself always getting them right. Okay, so let's now start the exam questions. I would suggest, if you are doing the exam, that you try these first and then listen back and check you've got it correct. So some of these questions will have bits from previous topics, and that's only because the exam questions will always be muddled up. So the expanding, for example, is what we've done before, but you'll be able to make the connection. So let's expand this. We've got x times x, which gives us x squared, and then x times minus 4. So that's expanding, so that's taking things out of a bracket. So we've got x squared minus 4x. Now we want to factorize. So remember what we said, we look at the numbers first. What goes in 15 and what goes into 10? Well, they're both in the 5 times table. So we're going to take 5 outside the bracket, and we say, how do we get from 5 to 15? We've got times by 3, and we've got y minus 2. And can you see there wasn't any letters the same, so there was nothing else that we needed to do there. Right, now we've got an equation to solve. So this was again what we were doing the other day. Now there's 2 ways to do this. You could open out the brackets, but like I said, it means 7 times all of it. So you can just divide both sides by 7, and you'd be left with f minus 5 on this side, and 28 divided by 7 is 4. Then to get rid of the minus 5, you're going to add 5. So f equals 9. And again, you can always check these. So you can do a check. 7, 9 minus 5. 7 times 9 minus 5, which is 4, which is 28. And you can always sort of check that you've done it right. And that's not a stupid idea to have that check constantly there. Okay, let's have a look at the next question. We're going to write some coordinates. So remember, along the corridor before we go up the stairs. So x coordinate goes first. So we want to get to this A. We're starting at 0. We're going 2 along. That's 2. Oops. And then we're going 3 up. And that's 3. And for B, well, if we start here, we're not going any along, but we're going minus 1 down. So it's always the x coordinate followed by the y coordinate. So now we've got a line and we want to find the equation for this line. So remember, it's a straight line. So immediately our brain goes, okay, straight line. It means it's y equals mx plus c. So we're like, okay, what is our m and what is our c? The easy bit is the c, is where it crosses the y-axis, which if you can see is over here. So this is my c. So straight away I can see that my c is minus 6. My m is a little bit trickier. My m is my gradient. It tells me for every 1 that I go across, how many up do I go? Now in a graph like this, you could just count it. So you can say, okay, if I start here, because it's a nice clear one, I go 1 across to 2. I go up 1, 2, 3. So my gradient must be 3. So my m is 3. So I'm going to get y equals 3x minus 6. Now the other way that you may have seen a gradient is to draw a triangle like this. And you may have learned it as rise over run, or the change in y over the change in x. So essentially you're doing this 3 divided by this 1. But we could have made that square bigger. So for example, if I had drawn the square as starting here and I'd gone 2 along. Oh, no, the graph doesn't let me go that far along. Don't worry. Let's see if we start over. Let's start down here. So if we go 2 along and then we go all the way till we reach the line again, that's 2, that's 1, 2, 3, 4, 5, 6. So we can do the change in y over the change in x, which is 2. So 6 over 2, which gives you 3, and you get to the same answer. But essentially what an m is for if every 1 you go along, how many up do you need to go? Okay, let's make this a bit smaller so you can see this. Right, so we've got some graphs and we've got to decide which ones are which. Right, so let's try think logically. We know that y equals mx plus c. We know this is my y-axis, this is my x-axis. So let's take this one, y equals 2. So that means everywhere along the line, y is 2. So the only one with a straight line where everything along that line, y is 2, is this one. Can you see? So if I take a point here, y is 2 everywhere along this line. So it'll always be a horizontal line for y equals. So that's D. Right. This one is y equals x. So there's no plus c, so we know it goes through the origin. So we can rule out A, B, and E, because we know it goes through 0, 0. The x is positive. So remember, a positive's graph starts low, goes up a slope, as if you're walking up. So it must be F. Also, we can see if x is 2, y is 2. So y equals x. And this last one, we could rearrange it. So y equals, we can minus x on both sides, minus x plus 2. So we know it's a slope going down. Oops. We know that the y-intercept is 2. So we know it crosses at 2. So we can cross out this one, and this. Oh, it could be this one. It could be this one or this one. So it could be A or E. We know it's a minus x, so it's going down. So it's starting high and going lower. So therefore, we can make that A. And you can check. You can say, if I pick this coordinate here, what's this coordinate? X is 2, Y is 0. So I'm like, okay, if I put X is 2 plus 0, yes, it equals 2. Right? This coordinate here is 0 and 2 again, and it definitely works. So that's one way you've got to pick. And it's only a couple of marks, so if something really isn't making sense, don't worry about it too much. Right, next one. We've got a straight line, and we've got to write the y-intercept, so where it crosses the y-axis. Really straightforward, it's 3. So it's when x is 0, y is 3. And then it says show the gradient is -2. So again, you just draw yourself a triangle. Ideally with, let me erase that. Let's draw a nicer triangle. So we're going to start somewhere. Let's go start there, for example. Go along and then go up. And we can say how many along have we gone. So we've got 2 here. We've got 1, 2, 3, 4 here. So if you think about it, if I'm going -2 and then up 4. So my change in y is 4 and my change in x is -2. So m equals 4, which is -2. But drawing that line will also just show, drawing that triangle will be fine. So now your equation is y equals -2x plus 3. So that leads on really nicely. Okay. Let's see. We've got another one where we're going to write the coordinates. So we want to write the coordinates of A. Our A is here. We're starting at 0. We're going along 6. So our x is 6. And we're going down 2. So y is -2. And then it says plot the coordinates 2, 9. Okay. So x is 2. So 2 along and 9 up. And we're going to label that B. Does the point B lie on y equals 4x plus 1? So this is saying when x is 2, what is y? So you have to say when x equals 2, y equals 4 times 2 plus 1, which is 8 plus 1, which equals 9. Yes, point B lies on y equal 4x plus 1. Right, then it says, on the grid, draw the line x equals -2. So remember, we said y equals something is a horizontal line. X equals something is a vertical line. So we find -2, and you will draw it with a ruler. You're going to go a straight line the whole way. So that's the line of x equals -2. Right, now we try to get some of the trickier questions, and you can tell they're trickier by just the number that it is. So this is number 28, so you know it's a little bit trickier. So we've got a straight line that has a gradient 4 and goes through a certain point. We see the word gradient, our brain goes, that's the m. So we know y equals 4x plus c, but we don't know the c. However, we know when x equals 5, y equals 23. So we can substitute them in, meaning wherever there's a y, we can stick 23, and wherever there's an x, we can stick 5. So we get 23 equals 4 times 5 plus c. So 23 equals 20 plus c, so c equals 3. So our answer is simply y equals 4x plus 3. Okay. And then we've got some simultaneous equations, and this is more like it. This is the kind of question that you'll get towards the end of a non-calculator paper, potentially. We're going to label them 1 and 2. And you can see that we've already got things that are the same. Both the y's are the same. So that means we can take them away from each other. So if the signs are different, like the examples we did earlier, you add them. If they're the same, you take them away. So we just do a take away sum. 7 take away 3 gives you 4x. 2 take away 2 disappears because it's 0. 36 minus 16, well 6 take away 6 is 0, 3 take away 1 is 2. So 4x is 20. We're going to divide both sides by 4 and we get x equals 5. And then what we can do is sub in 1. So we've got 7 times 5 plus 2y equals 36. So this is 35, plus 2y equals 36, minus 35 from both sides. You get 2y equals 1, and you'll get y is a half. And again, if you've got the calculator and it's a calculator paper, you can always check it in your calculator by typing it into that functions. So into that equation function. And don't worry if you don't have this calculator. You honestly, unless you plan on doing maths later, you don't really need it, but here's how you do it. However, if you're going to check it manually, you're going to plug check into, you're going to do 3 times 5 plus 2 times a half. 3 times 5 is 15. This is just 2 halves is 1, equals 16. That's also 16, tick. I know for definite I've done it right. Okay, so James and Elizabeth buy some clothes. So this is the simultaneous equations again, but it's a bit wordy. We're trying to work out what the question is. So James buys 5 shirts and 4 jumpers, and Elizabeth buys 3 shirts and 2 jumpers. Now I'm going to say shirts equals, just because we're used to using x's and y's, and jumpers equals y. So I've got 5 x's plus 4 y's equals 163. And I've got 3 x's plus 2 y's equals 89. Remember, we want to make something the same. It's much easier to multiply the second one by 2, and then we get the 4 y's the same. So you've got 89 times by 2. So 80 times by 2 is 160, 9 times 2 is 18, add them up, you get 178. So now I'm going to write the 1 underneath it, because I think it's easier to take away this way around, because of the numbers. I'm going to take away some. 6x minus 5x is just going to be x. 4y minus 4y is just going to disappear, because it's going to be 0. And 178 minus, so 8 minus 3 is 5, so we get 15. We now can substitute it back in. So 5 shirts, each £15. This means I've spent £75 plus 4y is 163, minus 75 from both sides. So 4y is 163 minus 75 to give you 88. Divide both sides by 4. So 88 divided by 4 is going to give me 22. So the cost of a shirt, which we called X, is £15 and a jumper is 22. And you can double check it. You can say, well, 3 shirts costing £15 each is going to be £45. 2 jumpers at £22 each is going to be £44. If I add up those 2 numbers, does it give me 89? Yes, I know I've done it right. So that check isn't really part of your working, that's more for yourself. Right, that's about half an hour. It's been a bit quick, I know, but we're going to try work through all of these. So that's session 4. You should see session 5 on Saturday and session 6 on Sunday. And I believe we're back on track with the original schedule. Hope this is useful. And if put any comments or questions down below and we'll try help as much as possible.